electrode potentials and cells. One second. That should be fine. Electrochemical cell made from two different metals, dipped in salt solutions of their own ions and connected by wire known as external circuit. Say what a salt bridge is made up of and function is. The salt bridge is made from a filter paper soaked in KNO3 aqueous, potassium nitrate aqueous. Allows ions to flow through and balance the charges. Electrons flow through the wire from more reactive metal to less reactive metal. Voltmeter in an external circuit shows voltage between two half cells. E cell is the cell potential. Half cells involving solutions of two aqueous ions of the same element. So where does the conversion of Fe2 plus to Fe3 plus happen and why? It happens on the surface of a platinum electrode. The reason being is that the electrode, therefore, if it happens on the surface of a platinum electrode, well, the electrode is made of platinum, and platinum is an inert metal, so it won't react with the ions. Reactions occurring at each electrode in an electrochemical cell is reversible. Half equation reduction reactions in the forward direction, reduction reactions in the forward direction, and negatively charged electrons on the left-hand side. What does direction each reaction goes depend on? How easily each metal loses the electrons, aka how easy each metal is oxidized. How easy each metal loses electrons, how easy each metal is oxidized. Electrode potentials measures how easily a metal is oxidized. If a metal is easy to oxidize, it's got a very, very negative electrode potential. If metal is harder to oxidize, it's got a less negative electrode potential, more positive electrode potential. Easy to oxidize, very negative electrode potential. Harder to oxidize, more positive electrode potential. Standard hydrogen electrode is used to measure electrode potential of a half cell. Standard electrode potential, E, like that symbol, voltage, is the idea if the voltage measured under standard conditions when the half cell is connected to a standard hydrogen electrode. Voltage measured under standard conditions when the half cell is connected to standard hydrogen electrode. Any solutions must have a concentration 1.0 moles per minus cube. Temperature must be 298 Kelvin. Pressure must be 100 kilopascal. But those two are common in a lot of reactions. This one, any solutions must have a concentration of 1 moles per minus cube. That's why I only included this one. Electrochemical series, a list of standard electrode potentials for different electrochemical half cells. A list of standard electrode potentials for different electrochemical half cells. And the formula, E cell equals E reduced minus electrode potential oxidized. ROR. So ROOR. That's the acronym to remember it. Reduced form, oxidized form, reduced form. Double vertical lines, these two show a salt bridge. And remember, salt bridge, I just went through at the beginning of the video, is made from filter paper soaked in KNO3 aqueous and allows the ions to flow through and balance the charges. Made from filter paper soaked in KNO3 aqueous. And just one vertical line shows things in different phases separated. So you go from a different phase. Separate. Half cell with more negative potential Half cell with more negative potential goes on the left. And that's really important. If you've got something like, I don't even know, silver and golden, for example, this is a random example, it might not be correct, and let's say gold has a more negative potential, then it will go on the left. Feasible reaction is when this is positive. Electrochemical cells are used as batteries. Now moving on to batteries, and this part is probably a bit easier because it's just a lot of content about batteries. So batteries type of electrochemical cell provides electricity to power things. Non-rechargeable batteries, they are cheaper than rechargeable ones. However, in the long term, rechargeable, we can reuse them, recharge them. Therefore, rechargeable batteries are cheap in the long run. Lithium batteries are rechargeable batteries found in phones, laptops, and cars. Mobile phones, laptops, and cars. One type of lithium cell is made of lithium cobalt oxide, LiCoO2 electrode, and graphite electrode. Electrolyte is a lithium salt in an organic solvent. So these two equations you do have to memorize. Li, arrow Li plus E minus, negative electrode. Li plus COO2 plus E minus to form Li plus. square bracket COO O2 minus. So Li arrow Li plus E minus, Li plus COO2 plus E minus to form Li bracket COO2 CO and then O2 bracket negative, and that's at the negative electrode, that's at the positive electrode. State how to recharge batteries. As the current supplied to force negative electrons, so current supplied to force the negative electrons to flow in the opposite direction around the circuit. So current supplied forces negative electrons flow in opposite direction around the circuit and therefore reverse the reactions. State two key facts about reaction non-rechargeable battery. Like the idea of recharging a non-rechargeable battery is difficult and it's almost impossible to reverse it in this way. Fuel cells generate electricity from hydrogen and oxygen. The chemicals are stored separately outside the cell and are fed in when the electricity is required. Compared to in most cells, chemicals are generated using electricity contained in electrodes and the electrolyte forming cell. So the example of fuel cells, alkaline hydrogen oxygen fuel cell, used to power electric vehicles. So hydrogen and oxygen are fed into two separate platinum containing electrodes. Electrodes are separated by an anion exchange membrane which allows ions OH minus and water to pass through it. So electrodes separated by anion exchange membrane allows anions negative OH minus ion and water to pass through it, but not hydrogen and oxygen gas. Electrolyte is an aqueous alkaline potassium hydroxide solution. Electrolyte is an aqueous alkaline potassium hydroxide solution. Hydrogen is fed to the negative electrode, 2H2 gases plus 4 OH minus aqueous to form 4H2O liquid plus 4E minus. Or the oxygen fed to the positive electrode, O2 gases plus 2H2O liquid plus 4E minus to form 4OH minus aqueous. And the overall effect of hydrogen and oxygen to form water, 2H2 gases plus O2 gases to form 2H2O. I think it's actually liquid here, maybe in gases, I'm not sure. Fuel cells, the more efficient, the only waste product is water. There's no toxic chemicals disposed of, and as long as hydrogen and oxygen supplied, the cell produces electricity. As long as hydrogen and oxygen supplied, cell produces electricity. However, hydrogen is extremely highly flammable, so it needs to be carefully handled when transported / stored. We also need energy to produce a supply of hydrogen and oxygen. And this energy can be produced by electrolysis of water. Electrolysis of water requires electricity, right? And that's usually generated by burning fossil fuels. And therefore, you could argue that not carbon neutral.